Welcome back to the second lecture of our course on calculus of several variables. So, let us look at the title of the lecture, inner product and distance. So, this notion of inner product and distance is going to play a fundamental role as we move along. So, what is an inner product? So, inner product has the following definition, which I will just give for 2 dimensional vectors first. So, you know that in 2 dimensions, if I draw the picture, so this is the 2 dimensional plane with x axis on as horizontal axis and y axis as the vertical axis. So, suppose I have 2 points P whose coordinates are x1 and y1 and some other point Q whose coordinate is x2 and y2. It could be anywhere in this plane, it could be here, 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 does not matter. So, I am just drawing for my own convenience, and here is the origin, which is the point 0, 0. So, the tip of this vector OP is the point P. Okay. So, this vector OP is actually represented by this set of 2 numbers which actually decide the direction as well as the magnitude, as we will see. And here is another vector OQ. So, I can call this as R1 vector OP and call this as R2 vector. I hope this drawing is clear. And so, now once this drawing is clear, please have a look at this drawing. Once this drawing is clear, then I define the following. So, your R1 vector is the OP vector, and which consists of points x1, y1. I am writing these as rows as in a horizontal way just for space, otherwise people usually write it as columns. R2 vector is the OQ vector, which has where Q has coordinates x2, y2, and now this inner product is also called the dot product. The inner product is defined as follows: R1 inner product R2 is, you take the first 2. So, I have told you that there must be a kind of way to talk about multiplication in higher dimensions. In you have 2 real numbers, you know how to multiply. So, if you have 2 coordinates, you know how to add them, that is what we have learned in the last class, and how to stretch them, pull them and all sort of things, but how to multiply them, what is the meaning of multiplication? There could be several meanings, so of course there are, but one of the most natural way is to look at each of the components, first component of this and first component of the other one, and then multiply these 2 numbers, and then keep on adding what we get and do component wise. So, here I take x1 multiply with x2 and I take y1, I multiply with y2. Of course, you should not forget that R1 and R2, physicists would like R1 and R2 to be represented as x1 into I vector plus y1 into j vector, and you know these are vectors 0 1, 1 0 and 0 1, and R2 can also be represented as x2 into I vector plus y2 into j vector. So, this is the definition of inner product. Now, once you know about 2 dimensions, you can talk about 3 dimensions, and how can I go to n dimensions? That is the question. So, in dot product in n dimensions. Dot product in n dimensions. So, how do I have, so suppose I have two vectors now, one is r1 vector which has coordinates x1, x2 up to xn because it is Rn, and then I have R2 vector which has coordinates y1, y2, yn, then the dot product, see the dot product is sometimes written like this R1 R2. This is called, when it is written like this, it is called the inner product. But anyway, you can call it dot product or inner product, whichever one pleases you or suits you. You can give any name, scalar product, some people call it scalar product. So you can choose, you can give your own name also. Now this is nothing but the same story will go on. So it will become x1 y1 plus x2 into y2 plus xn into yn, which in a more shorthand form can be written as summation I is equal to 1 to n xi yi. Or just to make physicists happy here, those who are in physics, this can be also written in kind of Einstein summation convention, that it can be written as x mu y mu, where mu is running from 1 to n. So, you once the indices are repeated, you basically this is a sum, that is all. So, now with the basic definitions in, we will now focus all our energy in looking at vectors in 3 dimension, because beyond 3 dimension it becomes largely algebra and visualization becomes slightly difficult. So, you have to view it through an algebraic angle than a pure geometric angle where you draw figures. So, let me now draw the diagram of a vector in 3 dimension, and I would like to figure out what is the distance of a given point in space from the origin. So, here is my 3 dimensional space. X axis, y axis, z axis. Now, here is a point P, so it is given by the coordinates x, y and z. Maybe I should put the point P here. So, this is the point P given by the coordinates x, y, z. Or I should write this point P is here and this is x, y, z. Now, the question is, what is the distance of O from P? So, we want to find now the distance of O, or P rather, P from O. So, basically I want to find the length of the vector OP, find length of OP. This length of the OP vector, it is sometimes called a the norm of OP. So, length of OP is sometimes denoted as the symbol Now, how do I find this length? The clue of finding this length is Pythagoras theorem. And let us see how I can apply the Pythagoras theorem to find the length. The key idea is that you drop a perpendicular from the point P straight onto the plane xy and see where it meets. It will meet exactly at the point whose coordinates are x, y and 0 and call this point as P dash. So, let us first see what is the length of. So, this if I drop, once I drop a perpendicular, this OPP dash, they form a right angle triangle. And now if I know the length of OP dash and then I know that this length is nothing but z, I can use Pythagoras theorem to find OP. So, what is OP dash? So, what you do, again drop a perpendicular on x axis from OP dash to come to a point which you call Q. So, this point is x 0 0, okay. So, you know that this distance PQ, this distance, the length of this distance is nothing but the value y. Here we are writing it in a positive, if we are in the positive orthant, it is, we are writing it as y, otherwise it is mod of y, the absolute value of y. Here it is x, OQ is x. So, OP dash square, if you take this vector and take the square of the length, which I can write as norm, length is written as norm, it is nothing but the length of OQ, square of OQ plus PQ square. So, this is nothing but x square plus y square. So, sorry, OP dash square. OP dash square is x square plus y square, and so what is OP square? Again by using Pythagoras theorem, OP square is actually OP dash square plus z square. Z square is, z is the length of PP dash, and here we are in the non-negative orthant. If it is not, it is mod z of square. So, this is nothing but mod z square and z square is the same thing, x square plus y square plus z square. This is called the Euclid's norm or Euclidean norm. This is OP is equal to x square plus y square plus z square. So, here you have square root of this, non-negative square root of course, because we are talking about length and length is never negative. So, what do I see from this expression? What do I see from here? What do I get from this thing? I get a very interesting feature. This idea of finding the length through Pythagoras theorem allows me to actually connect the notion of length and inner product, and let us see how it is done. So, if I call OP vector as R vector, then R vector can be written as x of I vector plus y of j vector plus z of k vector. This is very clear to you. Now, once this is known, you know, let us see what is the dot product of R with R. The dot product is nothing but x square plus y square plus z square, which is nothing but the norm of the vector OP square. Since OP is nothing but R, this is, so what I have a very interesting relationship here. Relationship is like this, sorry, R dot R is square of the length of R. This is an important relationship. and once this relationship is known, you know what is R. So, R vector is equal to root over R dot R. This is what we have. So, you see we have now linked these two things. What does essentially this OP is talking about? This is the length of a vector, a point from the origin. So, whenever I am talking about the length of the vector, it is the distance between the origin and the point which the vector represents. So, these vectors, OP vector is called the position vector of the point P, because it is establishing the position of P in space. You take some other vector, that will be position vector of that particular, take another point, position vector of the particular point Q. So, it is kind of vectors allow you to position the coordinates, and by that you see that because vectors to position a different coordinate to different coordinates, the vectors have to have different directions and different magnitude, different lengths, and as a result of which these points, these triads here, this coordinates, three coordinates, length, breadth, height, they can also be identified with a vector. So, these tuple of 3 real numbers can be identified with a vector because of this notion of position vector, because here is the point P. So, here is a vector, here is a different length, here is the point Q. So, here the direction has changed and the length is changed. So, if the 2 points, this point P here and Q here have different directions and different lengths from the origin. So, with respect to the origin, these can be thought of as vectors, and that is exactly what it is. And so, we are not just telling that whenever we have more than, whenever we have some real numbers accumulated in a chain x, y, z, w, we will call them vectors. We call them vectors because of this geometrical fact, because you can position them, you can identify their position in space by using vectors, by using geometrical vectors. Okay. So, let us now see certain important properties of the vector of the notion of a length. So, properties of length. So, property 1, length has to be always greater than equal to 0, obvious. Oh, what is the spelling obvious? Okay. So, this is an obvious property which we all understand. We cannot say something as minus 2 length. Second property which I admire, and it is a very interesting property, very simple but very interesting, is that the length of a vector, if it is equal to is 0, if and only if R vector actually identified with the 0 vector, R is identified with the origin. So, how do we do that? So, if R vector is identified with the origin, that is R vector is 0 I vector plus 0 j vector plus 0 k vector, then what happens? Then what is the length? Square of the length. So, square is equal to R dot R, and that is nothing but 0, because 0 plus 0 plus 0, 0 square plus 0 square plus 0 square. Now, suppose I have, so this would imply if square of something is 0, that whole quantity must be 0, it is very natural. So, suppose mod r equal to 0, then it implies that mod of r square is also 0. So, if r bar r square is x I vector, y j vector and z k vector, then it implies that 0 is equal to, here it means that r is identified with the coordinate space. So, r since square of the length is 0, this is nothing but r dot r. So, r dot r is x square plus y square plus z square, and this is equal to 0. So, what we get from here is that x square plus y square plus z square is equal to 0. So, now these are non-negative numbers x square, y square, z square. So, non-negative numbers adding up to 0 means all of them has to be 0. If one of them is non-zero, then the sum would be non-zero, which means that here x square equal to 0, x y square equal to 0 and z square equal to 0, which also means that x is equal to 0, y is equal to 0 and z equal to 0, and hence we can identify the vector r with the 0 vector, and hence this rule holds. Now, there is another interesting formula to calculate the dot product of two vectors in 3-dimensional space, and that makes use of the angle between the two vectors. So, let me use the board now. So, this going forth between the back end board and this electronic board, electronic slate is much better, because math is always traditionally been a subject of the board, and it needs to go back to the board sometimes. It is much more fun to see things being worked out. So, here I will have a scenario of two x y z, x vector, maybe I will increase the length of this part, x axis, y axis, z axis with the origin, and I have origin, let me write it here. I will have two vectors a and b. So, this is the a vector, this is the b vector, and this is the angle theta between the two vectors. They are representing two different points, say P and Q. We are not writing the coordinates at this moment. So, you observe that OPQ is a triangle. What we are going to show, that a vector dot b vector is equal to the norm of a vector into the norm of b vector, length of b vector, into the cosine of the angle between them. So, those who have some idea or liking for Euclid's geometry would immediately understand that some kind of cosine law has to be used. So, this vector PQ, if you look at this vector PQ, those with a basic idea of geometrical vectors would immediately know that this is representing the vector b hat minus a hat, b minus a basically. So, PQ is representing the vector. Now, if you look at the triangle OPQ, in triangle OPQ, apply the cosine law. So, once I know this angle here, I can actually use the cosine of this angle and the lengths of these two sides to find the length of this side, that is the cosine law, which you know. Apply the cosine law. So, how do I do it? So, I have to find the length of this, and I know the cosine laws are, you know, I am just writing down the this square is equal to this square plus this square minus twice this into this cos theta. So, b minus a whole square is equal to a square plus b square minus 2 to norm a b cos theta. This is what you know. Okay. Now, how do I go about doing this? I really have to play with this. This side I have done something. Here already this part has appeared, this part has appeared. So, some game has to be played here. So, let us see how the game is played, and once we try to play that game, we will see, we will learn some law about how to handle inner products. So, norm b hat minus a hat whole square is equal to the dot product of b minus a into b minus a. So, it is b minus a vector dot product into b minus a vector. Now, how would I actually do this inner product, do this dot product? Just think as if you are really multiplying numbers. So, you can actually do this, you can do b hat minus a hat dot product of b hat minus of b hat minus of b hat minus of a hat into a hat. So, you see you are playing just as if you are multiplying numbers. Again do the same game here. So, remember the thumb rule, multiply, take the dot product as if you are really taking dot products of numbers, ordinary numbers, but instead of the multiplication you will put the dot product. It is that easy to remember. So, of course I can prove them, you know, of course I can do things, prove that what I am doing is really true, the dot product of these two is exactly this. But I am just telling you the thumb rule, because sometimes, as John von Neumann said, you do not understand things in mathematics, you just get used to them. So, sometimes you go by the thumb rule and later on you can check for yourself with simple examples that is indeed working, you can actually prove it in detail. So, let us just do this. So, I will have b dot b minus a dot b, here I have minus b dot a minus plus a dot a. So, what do I get? I get this, by definition it is square of the length, here I have minus 2 a dot b, because a dot b and b dot a are the same thing, because ultimately these are nothing but multiplication of numbers and summed up, and because standard multiplication of real numbers is commutative, x into y is same as y into x, and hence you have this one and you club them together plus norm. So, this is what, so this side is this. So, taking in what I have here, I will plug it into here. So, what do I get? I get, I hope this is not blocking, if this is blocking I will just go to this side. So, I get now norm b square minus 2 a dot b plus norm a square is equal to norm a square, just this is equal to this. So, I am writing down the right hand side. So, this is nothing but this. So, the right hand side is equal to that b hat square minus 2 the Euclidean geometry is at action here. Now what you do here is you know that I can cancel this with this with this, the negative signs can be cancelled and so 2 can be cancelled, and what you have is at the end this implies that A dot B is nothing but voila, as the French would say voila, means that is it, done. So we have done this. So once you know that A dot B is equal to mod norm A into norm B into cosine of the angle between them, then you can definitely write if norm A is not equal to 0, means A is not equal to 0 and norm B is not equal to 0, then you can obviously find theta as inverse cos inverse of A dot B by okay. Suppose we have this scene, suppose we have two vectors and none of them are 0, and suppose A dot B is 0. So if now in this case if this holds, that is this is not 0, this is not 0, and if A dot B is 0, then from this above inequality then theta equal to cos of 0, which is pi by 2, 90 degrees. So if you think of cos inverse as a function, cos inverse is really not a function, it is a multifunction, because for one particular value it can have many thetas corresponding to it. But if you just take the acute angle values, then it becomes a function, the principal values, then cos 0 is pi by 2, which means if A dot B is 0, then the vectors A and B are perpendicular. In fact, if A and B on the opposite side, if A and B are perpendicular, then theta equal to pi by 2, and it immediately implies that A dot B is equal to 0. So you see this, the fact that A dot B equal to 0 makes the two vectors perpendicular, the theta becomes 90 degree. So if it is one is here, the other is here. This is possible because of this formula, this alternative formulation of A dot B. So because of that you could now do such a thing. Try to figure out make some vectors yourself, play around a bit and see, because we are also constrained by time. And so what we are going to do, we are going to talk about an interesting thing called Cauchy-Schwarz inequality. So what is Cauchy-Schwarz inequality? Actually Russians won't like just to call it Cauchy-Schwarz inequality, they would call it Cauchy-Schwarz-Bunyakovsky's inequality. So there are a lot of credits giving in mathematics that okay, Russians said okay, we had done it sometimes without knowing what you guys were doing in the West, and they would, Western would say no, Cauchy is a great man, his name has to be there. But it seems several people earlier also knew it. In fact, as I know that Lagrange, if I am not wrong, Lagrange possibly knew about this idea. So, but some stories remain and some stories do not, and so we call it the Cauchy-Schwarz inequality. Inequalities actually are the hallmarks of mathematics. What does it say? What does Cauchy-Schwarz inequality says? Cauchy-Schwarz inequality says that if you take the dot product of two vectors, is a real number, it could be positive, negative, anything, and you take its modulus value, absolute value, then this absolute value is less than the product of the length of these vectors. That is what the Cauchy-Schwarz inequality says. So, let us prove this Cauchy-Schwarz inequality, and you will see that Cauchy-Schwarz inequality is nothing but a consequence of this formula. Why? Let me tell you. So, you see proof. Let me pose like a mathematician, though I am truly not one, but I am posing as if I am, and then I am writing this word proof and trying to prove that this happens. So, that the Cauchy-Schwarz inequality. So, I know this formula which we have deduced there on the blackboard. Here it is, here is the formula. So, what I do, I take the modulus of both sides, and you know that if I take the modulus of a real number, of a positive non-negative number, so the non-negative numbers will just come out, it will remain, the modulus is the same, modulus of 2 is 2, but modulus of minus 2 is 2 also. So, if it is not a negative number, the modulus does not change. So, it is just, so if I take the modulus, it is this into cosine theta, modulus of cosine theta. But you know the cosine value lies between plus 1 and minus 1. So, absolute value of cosine theta has to be always less than 1. So, it simply means A dot B is less than equal to, how beautiful the proof is, very simple as a consequence of that idea, that derivation. This is the beauty of mathematics. I think this is a beautiful thing. So, here is my proof of Cauchy-Schwarz inequality. Okay. Now, I come to the third property of length. Third property of length is another way of telling a very standard geometrical fact which you know, that given a triangle in plane, the sum of two sides of a triangle is greater than the third. So, if you have a triangle in space, basically you can think of the triangle as a part of a plane, it is lying in a plane essentially, though it is in a 3-dimensional space we are talking about, but still, for example, here this triangle OPQ, you can think of that it is lying in the plane that is passing through these 3 points. So, again that idea is built into what is called a triangle inequality. So, it does not matter whether you are in 2 dimension, 3 dimension or n dimension, this is true. It says that this so we have two vectors, say x and y, then x plus y is less than mod x plus mod y. You can write AB also, we have been writing AB, so it does not matter whatever, whichever. So, what I do, the same thing, if you want I can write this as A dot B. In fact, that is a better thing because it will be easier for you to follow, because the Cauchy-Schwarz inequality is written in terms of A and B, right, though it does not matter, these are all dummy things, A or X is same. when you know the meaning, but I just don't want to confuse you on the notation. So, let me just do the job here. So, now I consider a plus b whole square, the same game. This is the name of the game, squaring up and then writing this as a plus b dot a plus b. If you do it, work it out, then it will become a square plus b square plus 2 a dot b. Okay. And once you know this, now here, so I can apply the Cauchy-Schwarz inequality and write this is less than equal to square plus mod of norm of b square plus, so this part is less than 2 times norm of a into norm of b. This is the Cauchy-Schwarz inequality. This is where I have applied the Cauchy-Schwarz inequality. This is something you have to keep in mind, that this is where I have applied the Cauchy-Schwarz inequality, and hence once I have done it, it is very simple. So, I have got a plus b whole square. Now, if I write this, this is nothing but mod a plus mod b whole square. So, now I cancel, I know there are two non-negative quantities whose square of one is less than the square of others. This simply means, and again voila, we have done it, and this is a very key inequality. I think I am stretching this talk a bit, but this is a very important part. This is the first, you have been equipped with tools. I hope this chalk is been clear. I hope this is a much clearer chalk. I hope you will be able to see this. I do not know, maybe I should go near the board, and I guess at least it can be seen. Maybe I would write to make it more brighter. Maybe make it more brighter. I do not know whether I should do it. I hope you would understand it. In case you do not, I just repeat the proof here, so that you, the main idea that what you do is to take a plus b whole square, and this would give you nothing but a plus b dot a plus b, and that leads to norm a square plus norm b square twice a dot b, applying the formulas of computing inner products, and now applying Cauchy-Schwarz inequality. You will get this. And then that simply shows that a plus b, so I am reworking the proof here in case the thing that you do not see the whole thing clearly on the board, compared to that writing that was much more deep, cleaner. So, and that is it. Once you know that, then this is nothing but norm a plus norm b whole square. So, this implies, because there are two numbers which are so triangle inequality is done. So, with this I end today's lecture. There is something called projection formula. The projection formula would be given in an assignment, and I am trying to have some notes written down for the first few chapters which are very basic, and this I will hand over to the NPTEL's staff here, so that they can actually scan them up and put them on the course website. So, you have some basic idea now of how to do things, and that is very important to have a basic idea. So, I hope you have understood it there. If you have not, you please feel free to ask questions. You can even ask very fundamental questions which I might have forgotten to tell you, or I might have skipped for some reason, or it might be I myself do not know. So, please feel free to ask questions, because at the end mathematics cannot be learned without discussions. Thank you.